Welcome to This Explainer. Today, we're diving straight into a topic that's pretty much everywhere right now, the real, actual differences between artificial intelligence and the human brain. And look, we're going to do this without the hype and without the sci-fi panic. If you've ever found yourself wondering where we humans really stand next to these massive machines, stick around, because we're going to break this whole cognitive divide down layer by layer.
To kick things off, I want you to just picture this for a second. A modern AI just read, analyzed, and fully processed the equivalent of a 500-page book. And it did the whole thing in exactly 3 seconds. I mean, that is literally like digesting a massive textbook in the time it takes you to blink. It's a completely mind-bending volume of information. But seeing that incredible speed leads us right into what is arguably the most important question we can be asking right now. Sure, it read the text, but did it actually understand any of it? It sounds like a simple, maybe even philosophical question, but how we answer it, well, it completely rewrites our entire view on the future of medicine, the legal system, and honestly, our own humanity.
Okay, so here's our roadmap for this explainer. First, we'll define intelligence. Second, we're looking at AI's processing advantage. Third, we'll dive into embodied human intelligence. And fourth, we'll wrap up with hybrid systems and the actual real-world risks.
All right, let's jump straight into Section 1. Defining intelligence, or, as I like to call it, the problem before the problem.
So, trying to measure intelligence with just one single number or metric, it's kind of like trying to capture the vibe of an entire sprawling city with just one Polaroid picture. It doesn't really work. Take GPT-4, for instance. It can absolutely crush the bar exam with near-perfect scores, but then it completely fails at the basic causal reasoning you'd expect from a preschooler. Why is that? Because intelligence is incredibly broad. It covers everything from raw processing speed all the way to navigating fuzzy ambiguity and sudden context shifts.
And that brings us to an absolutely crucial distinction: processing intelligence versus embodied intelligence. When it comes to executing well-defined, strict tasks perfectly every single time, AI completely dominates. But humans? We have this undisputed mastery of reading the room, figuring out highly ambiguous situations, knowing when to break the rules, and acting on deeply held internal values.
Moving right along to Section 2, the processing advantage. Let's talk about speed, volume, and consistency.
Get a load of this number. Current large language models are trained on anywhere from 1 to 3 trillion tokens. That's hundreds of billions of words. To put that into perspective, if you read at a steady, normal pace for your entire life, you're going to process maybe 10 to 15 million words tops. We aren't just talking about a different order of magnitude here. We are literally not even playing the same sport.
And this insane volume advantage, it translates into some massive real-world applications. Take Mount Sinai Hospital. They used a model to chew through 700,000 patient records, spotting these tiny, invisible correlations to predict Alzheimer's years before symptoms showed up. I mean, no human doctor could read 700,000 charts. In the legal world, Harvey AI is digesting thousands of contracts in mere minutes. And in biology, AlphaFold 2 basically solved protein folding, a puzzle that had scientists stumped for 50 years. AI spots patterns at a scale that just entirely bypasses our human physical limits.
But humans have limits beyond just reading speed. There's this famous study on judges in Israel that shows something pretty alarming. The chance of a judge granting parole is around 65% right after they've had breakfast, but right before lunch, it drops to almost zero. It's called decision fatigue. We get hangry, we get tired. AI, though, AI doesn't get hungry. It doesn't care if it's a Monday morning. Its absolute consistency is incredibly valuable when you need the 10,000th decision to be handled with the exact same care as the very first.
Actually, hold up, let's pause here, because we need to be really clear about something. Pattern recognition is not understanding. Yes, an AI model from Google Health managed to reduce breast cancer false negatives by almost 6% by finding complex statistical correlations across millions of scans. That's amazing. But predicting the next statistically correct pixel, or the next word in a sentence, doesn't mean the AI actually knows what cancer is. It doesn't truly comprehend the reality of a disease or the meaning behind a text.
Which brings us right to Section 3, embodied human intelligence. This is all about the knowledge that literally comes from having a physical body.
The consensus in neuroscience right now is pretty clear on this. To actually understand pain, you have to have experienced it through a physical state. When an AI generates the word pain on your screen, it's just doing math. It's calculating the statistical probability that the word belongs there.
But when you or I talk about pain, we're pulling from a subjective, cellular memory of having actually felt it. The machine has no nervous system. It feels nothing.
So our biology is actually our greatest strength. It's the human advantage. Things like common sense and causal reasoning, they come from us physically bumping into the world. We know that if we knock a glass off a table, it shatters. Simple, right? Yet tests like the Winogrand benchmark show AI still gets tripped up by this basic physical logic. And then there's creativity. A musician writes a heartbreaking song because they've lived through heartbreak. AI can remix existing words beautifully, sure, but genuine, paradigm-shifting creativity comes from lived, messy, subjective human experience. All right, let's bring it home with Section 4, hybrid systems and the actual, real-world risks we're facing. Out in the real world, the most effective systems today are not strictly AI, and they aren't strictly human either. The magic happens when humans work alongside machines. Look at education. Platforms like Khan Academy use AI as a tutor to instantly spot exactly where a student's math skills are lagging, at scale. But it's the human teacher standing next to the desk who notices the kid is crying in frustration, reads that emotional context, and steps in with empathy. The AI does the detecting, the human provides the context, and takes the responsibility.
So what should we actually be worried about? Forget the sci-fi tropes of robots taking over the world. The real, immediate danger is way more mundane. It's an opaque, automated system instantly denying you a mortgage, and there's no human around to take accountability. It's our own overconfidence, where we believe in AI's hallucinated facts just because it sounds incredibly confident. And honestly, the biggest risk might be the atrophy of our own skills. If we outsource all of our critical thinking to a machine, we're going to lose the ability to realize when the machine is dead wrong.
Let's wrap this up and take stock of what we know and what we don't. We know absolutely for a fact that AI dominates when it comes to processing, speed, and massive scale. That's undeniable, and it is reshaping every industry as we speak. But we also know it completely lacks the foundational, physical, and subjective experience that makes us human. What we don't know, and we just have to be intellectually honest about this, is whether future AI models will somehow evolve to close that gap.
So, I want to leave you with one final thought to chew on today. Can real, deep, transformative creativity actually exist if it doesn't depend on the subjective, human experience of living, feeling, and suffering in the real world? It's definitely something to think about the next time you're reading an article or looking at art generated by a machine. Thank you so much for joining me for this explainer. Stay curious and keep asking the big questions.